Hello everyone, my name is Priyadarshini and I'm from Nehru Institute of Engineering and Technology, Coimbatore, Tamil Nadu. And today I'm excited to present my embedded system internship project, which focuses on the simulation of washing machine using the Picsimlab at Emertxe Information Technologies. And during this internship, my learning objectives were to gain a solid introduction to the embedded systems and the basics of embedded C. And I also explored into the microprocessors and microcontrollers, especially learning how to work with the PIC 16 F877A. And also, finally, I gained practical experience with the implementations. So let's begin with the fundamental question. What exactly is an embedded system? Simply, an embedded system is a special purpose computer designed to perform dedicated functions within a larger system. So they are categorized by real-time operations and are compact and also power efficient and are typically based on the microcontrollers or microprocessors. So these systems are hardwired for specific tasks and common examples were including the washing machine, ATM and smart watches. So to program this system, we often use the embedded C. So this embedded C is an extension of the C program language, specially optimized for microcontrollers and embedded systems. It offers the key features such as the direct hardware access, efficient memory usage, and real-time execution, and portability across different microcontrollers. So, C itself is a general purpose and high level programming language known for its low level memory access and also speed, efficiency, and portability. So, our project utilizes the PIC 16 F877A board, and this board operates at 20 MHz and has a flash memory of 360 bytes and EEPROM data memory of 256 bytes, and it features like 15 interrupts and uh, 5 input output ports A, B, C, D, and E. So, the board also includes the three timers and two PWM modules and various components like a CLCD and a fan and tactile switches, also buzzer and LED, ADC and RS-232 were included. So our primary objective is to create a virtual embedded system environment that accurately simulates the operation of a washing machine, and this allows us to test and refine our design without the need for physical hardware in the initial stages. For our microcontroller platform, we selected the PIC 16 F877A. So this choice was deliberate owing to its robust set of input-output features and versatile timers. For software tools, we used MPLab X IDE to write, compile, and debug our embedded C code, and Picsimlab for visual testing of hardware behavior. So the X8 compiler was used to convert our embedded C code into machine-level instructions. So coming to the project requirements, MPLab X IDE is a special free computer program made by a company called Microchip Technology, and you can think of it like a complete workshop where you build the software for tiny computer chips, and people use it a little for a lot for writing and programs like finding and fixing mistakes in those programs, and generally creating the brains for things like washing machines or other smart devices. So it especially good for the chips made by a microchip like PIC, DSPIC, AVR, and SAM. And what's great about it, it's easy to use and it helps you test your code virtually to see how it will act and fix problems while your device is running, and even your code work faster, and it's super flexible. You can use it on Windows, Apple computers like Mac OS or Linux. Another tool which is used here is the Picsimlab. And the Picsimlab is a free computer program that lets you test your electronic projects without needing the actual parts. It's like having a virtual lab right on your computer, and it can pretend to be many different popular circuit boards like those with PIC chips, Arduino or STM32 or ESP32 and more. So this means you can design your project and then see how it works on your computer just as if you had the real board in front of you. And this tool is super useful for trying out your software, checking at different parts of your project and working right, and testing your whole electronic devices. You can and you don't need to buy any physical parts yet, which saves time and money. So it helps you quickly try out new ideas, find and fix problems in your code, and learn all about how embedded system work all in a safe and virtual place. So here I explain how we are using the Picsimlab for our washing machine project. And our main goal for this project is to stimulate the basic things a washing machine does, but in virtual world using PIC SimLab. So this means we are creating a computer version that acts just like a real washing machine. And this computer simulation will show us all the important steps a washing machine takes, like filling with water, washing clothes, rinsing them, and finally spinning them dry. So all of this is controlled by a small computer chip called the PIC16F8778 board, which we programmed, and the simulation will also show how different choices you make, like how many clothes you put in, the water level, or the type of fabric, change how the washing cycle works. So, to make this simulation feel real, we are including several virtual parts or peripherals. So, the CLCD will show us what the washing machine is doing at any moment, and a fan will represent the drying or spinning part of the machine, and a buzzer will make a sound to let us know when something important happens during the wash, and switches will let us choose different settings like the wash mode, and a timer will control how long each step of the washing process takes. So this is the block diagram of our washing machine system, and at the very center of the system is the microcontroller. This is the brain that receives all the instructions and sends out commands to make the washing machine operate. And on the left side, you can see the inputs. There are the ways we tell the microcontroller what to do or what's happening in with the machine. And we have the power on switch, that is switch 5 to turn on the washing machine, and a pass stop switch like the switch is 6 and to control the washing cycle, and navigation switch, that is switch 4, which allows us to select different options or modes, and a door a status sensor, that is switch 1, which tells the microcontroller if the washing machine door is open or closed. All these inputs send signals directly to the microcontroller. And now on the right side, we have the outputs. So there are what the microcontroller controls or uses to uh, show us information. So the display CLCD, so which we mentioned earlier, will show us the current washing status, and the buzzer will make a sounds for alerts or notifications, and the motor will represent the actual movement for washing, rinsing, and spinning action. So this diagram clearly shows how our user actions and the machine status flow into the microcontroller, which then processes the information and controls the various parts of the washing machine. So coming to the components used and starting with the tactile switches. So these switches are essentially momentary buttons. This means they only work when you press them down and they spring back up when you let go, and they are perfectly for the uh, perfectly used for quickly giving commands to our electronic systems like a washing machine. And in our project we assign specific jobs to different switches, connecting them to a particular pins on a microcontroller. And the RB3 is used to scroll through different wash options. So you can press this to choose between say a delicate wash or a heavy wash, and the RB4 is the power on or resume button. So this will turn the washing machine on or continue a cycle if it was passed. And also the RB5 is for pass or stop the cycle. So this gives you control to halt the washing process whenever needed. And finally the RB0 is very important for safety. It used to detect if the washing machine door is opened or closed, and this ensures the machine won't operate if the door isn't properly shut. Continuing with the other component which is used in a washing machine simulation, so let's now focus on the CLCD, which stands for the Character Liquid Crystal Display. And the CLCD is essentially the screen of a washing machine, and its main job is to display the current state of the machine. So just like a real washing machine, it shows you how what's happening at any given moment, and it's designed to show important information about how the machine is working. And it also help us navigate through different settings using the switches we just discussed. And also think of it as your main window into the washing machine operations. And beyond showing the current status, this displays is also smart enough to show you the time remaining until the washing program finishes. And this is very a helpful feature for users, and it also clearly indicates the current wash mode that has been selected, whether it is delicate cycle, a heavy wash, and any other option. So the CLCD is a vital component that provides a real-time feedback and also allows for user interaction and making our simulated washing machine feel very much like the real thing. And this timer is the vital for controlling washing cycle durations, and it ensures each step happens for the right amount of time. And our washing process has three stages, and those were wash, rinse, and spin. So in the wash for cleaning clothes, and the rinse for the to remove soap, and spin to remove water. And each stage runs for a preset time and managed by timer logic for efficiency. And these timers are displayed on the CLCD showing progress. And timers are essential for a realistic washing machine simulation controlling the entire process. Next is the buzzer, and the buzzer is used to indicate the important events during the washing cycle. And think of it as the sound system for a washing machine gives us audio cues. So one key function is that it sounds an alert when the washing machine door is opened. This is a safety feature triggered by the RB0 pin, and it immediately lets the user know the door has been opened and while the machine is operating. And additionally, the buzzer will beep for 3 seconds to signal the completion of the washing cycle. And this is convenient way for the machine to tell you that your laundry is done and ready to be taken out. Final component used is the fan, and in a project the fan is used to simulate the spinning motor of washing machine. Since we are working in the virtual environment, this fan helps us visually represent the powerful spinning action that happens during the wash and especially the drying cycles. So how does it work? The fan starts rotating as soon as washing mode is selected, and once you chosen your uh, washing cycle, the fan will begin to spin and will keep running throughout the entire washing cycle just like a real washing machine motor. And there's also an important feature, um, safety feature, that is connected to the fan. If the door is opened while the fan is spinning, which is detected by our RB zeros, which we discussed earlier. So the fan will pass automatically. This is a crucial safety measure preventing any virtual accidents. Once the door is safely closed again, the fan will automatically resume its operation and continuing the wash cycle. So now let us look at the project demo and the washing machine. So this is the demonstration of our project, and when we press the key 5, it will power on the washing machine and we can navigate through it through the switch 4 and the and this RB3. To select an option, we should long press the switch. So for now we have been selecting the delegate here, which shows the water level, and we can navigate through it. We can select the medium here. So here the switch 5 to start and the switch 6 is to stop. So when we press the switch 5, it starts the timer, and if we select the switch 6, it passes the program, and if we press the 5, it starts. When we press RB0, that is the switch, when it indicates the door is open and produces the buzzer. So here it shows the washing mode. And it finally shows that the washing is completed. So to conclude my presentation, this project centered around the PIC16F877A microcontroller serves as a powerful demonstration of how embedded systems can be practically applied in the real world appliances, and we moved beyond theoretical concepts to build a functional and a system that mirrors the complexities of an everyday device. And this hands on experience has been invaluable in understanding the things of microcontroller programming and system integration. It's truly exemplifies how a digital intelligence can be woven into the fabric of our physical world. So, our simulation clearly highlights three fundamental benefits that microcontroller based designs bring to everyday machines. So, their reliability, their flexibility, and the precise control they offer over operations. So, the reliability means that once programmed, these systems uh, perform their task consistently and predictable cycle after cycle. So, minimizing errors and ensuring dependable operations. So, think about how many times you use a washing machine, it's reliable, and flexibility refers to the ability to easily adapt and customize the machine functions. So, with a microcontroller, we can change wash cycles, add new features, or adjust a parameter simply by updating their software without needing to redesign the entire hardware. So, the adaptability is the key for future upgrades and meeting diverse user needs, and the precise control offered by these systems also allows the management of every step of the washing process, from exact water levels and precise spin speeds to timed operations and safety interlocks. So, this level of control optimizes the performance and ensures the longevity of the appliances. And by understanding this and actively programming these embedded systems, we gain the knowledge and about how intelligent automation is developed, and we've seen how simple inputs from switches translated into the complex automated sequences that manage the water and motor and display. So this fundamental knowledge is crucial because intelligent automation is not just about convenience, it's about efficiency, resource management, and the enhancing user experience across countless applications. So, this understanding plays a truly critical role in the advancement of the smart home technologies, making our living spacious, more connected, and responsive. So, furthermore, it contributes directly to the evolution of the modern embedded solutions that are at the heart of the countless innovations from industrial machinery to medical devices. So, this project has been more than just simulating a washing machine. It has been a journey into the core principles of embedded system, demonstrating their immense power in bringing intelligence and sophisticated automation to common appliances. So, it shows us the exciting possibilities that lie ahead and paves the way for future innovations in the world, increasingly reliant on smart and automated solutions. So, I just need to thank for Emertxe for providing this invaluable internship opportunity. Thank you.